Hello, hello. Welcome back, AP Psych students. For our next unit here, we're going to be diving into sensation and perception. This will be Unit 4 in your book and Unit 3 in the CED on College Board. So these are the modules that we'll be discussing, 16 through 21, for this next series. Now, what I'd like you to do is I would like you to go ahead and complete this assignment. I guess it's like a little bit of out of class reading. I would like you to go to this website here at Hanover College, and we're going to have a brief discussion on this when we get back to class. So just kind of look through the website, write a brief little summary. Nothing much. 2-3 sentences regarding one of the things that you found interesting within the website regarding this topic, sensation and perception. And then I'll make a little PSL drop box or comment box for you guys to put your little summary in regarding what you found on this website. And then you can recall it when we come back to class. So here are the learning targets we're going to be discussing today. We're not going to talk about everything in this. Some of this we'll talk about a little bit later, like transduction. But we will discuss the majority of this stuff in terms of how we organize and make sense of the world and all the stimulus around us. We'll talk about some of these common principles in sensory, like absolute threshold, difference threshold. We'll talk about Weber's law, and sensory adaptation, and then we'll discuss and talk a little bit about how culture can also influence our perceptual processes regarding context effects. So what is sensation? What is perception? All right. Well, when you look at this image here of Darth Vader, okay, how do we get that picture in our mind? How does it make it there, right? Well, it happens through these two things, sensation and perception. So sensation is the process by which our sensory receptors receive stimuli, okay, energies in our environment. Okay, that could be anything through ears, anything through our eyes, our nose, our tongue, our skin receptors, right? Anything from our environment that is then gone to processing, right, for further understanding, for further perception of the environment around us. Okay, so an example of sensation here that I have on the screen would be sound waves or lights that you might see. Okay, perception is the process by which we organize that stimuli and interpret those sensations to further understand the environment or the image or the sound that we are hearing, right? So an example of this could be an American flag, right? If we just look at the American flag, it's just generally a bunch of colors and shapes and lines. But when we see that, it actually has a sense of meaning, right? To me, it's a country that I am from. It's a symbol of patriotism, right? For my own flag, right? There's a meaning to it. So when I see that, it's more than just blue, blue blotches on a blue and red and white blotches on a piece of fabric. It means something to me. Okay, same thing with your flag, right? Your country flag. So let's look at an example here of sensation and perception working together. All right, so here we have an example of this image, a rose. Okay, we're going to process this rose. So if we technically speak about what a rose is, or if you look at that image, you don't build off of your previous schemas of what a rose is, right? It's just a intricate red form with a linear green stem and some leaves on it, right? Okay, so that's what a rose technically is, but it means something more to us. So how does this happen? All right, it happens through our sensory organs, our sensory receptors, in which we detect stimuli in our environment. In this case, we're going to be using the sense of smell. So it's called chemoreception, which you don't need to know that, but it's a process or sensation of using our smell. So here, in this example of sensation, this environmental energy that we're going to be referencing for transduction is going to be odor molecules. Okay, so these odor molecules are going to be processed and activated through our brain, and before it reaches our cerebral cortex, it's going to hit our olfactory bulb. And this organ, the olfactory bulb organ, is then going to transduce that information to a energy that our brain can transmit, right? And that's called a neural impulse, which we learned in our previous chapter. And then this is going to be processed by our cerebral cortex, and then our medial temporal lobe, and our limbic system, and our hippocampus, right, for memory. And then we're going to have an explicit memory and say, oh, it's a rose, if we're basing it off of smell. So the reason someone may need to use smell to be able to recognize what a rose is they might have something like visual agnosia. It's a real thing, and it's basically when people are unable to recognize objects through sight. So if you can't recognize objects through sight and you see that rose, and to you it's just a intricate red form with a linear green stem, okay, then you would be dealing with visual agnosia. You actually cannot recognize what things are around you. Okay, it'd be incredibly difficult to walk around life that way. So, in conclusion, perception equals decoded neural messages being transferred into meaningful interpretations. So within sensation and perception, you've got this thing called feature analysis, and there are two types of feature analysis that we use to basically detect specific elements that we're seeing or hearing or smelling to come up with this meaningful perception of what we're experiencing. All right. So the first is bottom-up processing, and the other is called top-down processing. So with bottom-up processing, this feature analysis starts from our raw senses. It starts from our senses. Okay? It doesn't start from our perceptions. It doesn't start from our past experiences. It doesn't start from our expectations, but it's starting from our sensory inputs. And so once we go through these sensory inputs, it's a much slower process than, say, top-down processing. But eventually we're able to take all of these different pieces of stimuli and make a meaningful whole, right? That's the whole purpose. We want to make a meaningful whole, gestalt, right? And so if I gave you a flag test and I said memorize these 28 flags, you would have to use bottom-up processing to individually look at all of these shapes, at all of the colors, at all of the lines, to be able to recognize them when you see them immediately, right? Well, I can look at that and immediately see, oh, American flag's right there, okay? I can see it within it because I've learned that flag, right? It has meaning to me. But you would use bottom-up processing to interpret, what all of these different flags mean. Another example, okay, could be more related to an auditory example. Let's say you're trying to understand what's being said in a conversation in a language that you're not very proficient in. Okay, maybe you just have rudimentary understanding of that language. And so you're going to listen for just bits and pieces of information, and you're going to pull those pieces of information together, and you're going to say, this is what they're trying to say. This is the meaning of their message, right? That's another example of bottom-up processing. So you're taking individual units from your senses, pulling them together to then make a meaningful whole, okay? So first you detect specific features of the stimulus, then you can combine those things together to more complex forms, and then you're able to recognize what is being said or what is being seen, etc., etc. So look at this example. What does this represent? It represents two things. See if you can guess them. So the first thing it obviously represents is top-down processing, okay, which we haven't talked about yet, but we're going to in a minute. The other thing it represents is context effects. So context effects are basically just the context in which a stimulus can be seen through your own perceptual hypothesis. Okay? On the left, that H is an H to you, right? And then on the right, that A is an A to you. However, it's really nothing. Technically, those are both written incorrectly, but you interpret them through your own hypotheses, your own perceptual hypotheses, to mean the letter H and the letter A, so that it stands for the cat. Okay? This is an example of contextual effects and top-down processing, because you're using your previous expectations of what those should be and prior experiences to therefore form your perception. So let's look at top-down processing a little bit more here. Top-down processing is the information processing from which we use our prior expectations or experiences to therefore interpret incoming sensory. Okay? Positives to this, right? Well, you're able to experience the world in a much more efficient manner, right? Okay? You know what food is, you know what water is, you know what transportation is, you know how to read when you're trying to get around new places, new cities, and when I give you your assignments, right? So be very thankful that our brains can process this way. Negatives to it, of course there are negatives, right? It could lead to this image here, silly image of police cars at a donut shop, right? It's just like a stereotype that we have of police officers. I don't know if it's the same here in Hong Kong, but it's a stereotype that's, made in the U.S. where police officers, all they do is drink coffee and eat donuts and drive around. Okay, now there's a lot of different other perceptions, right? Stereotypes about what police officers are, especially in terms of this whole BLM movement that's going on in the U.S. That's definitely a negative of top-down processing, but it's still very important for us to function in this world. So I don't want to get off the main point of what I'm talking about here. So some examples of this could be like, you just recognize things. Like you look up in the sky and you see, oh, it looks like a bunny, or it looks like a duck, or it looks like a person, right? And the reason we're able to do this is through top-down processing, because we have developed these expectations and experiences with these specific shapes. Or the first day you walk into my classroom, okay, why did you know I was Mr. Vogel? Right? Because you've had certain experiences that generally when you walk into the room and the person standing at the front of the room with their laptop open and they're dressed differently than the students, right? Most of the time that's probably the teacher. So we have these expectations and these experiences that form our perception of the world. Okay, here's another example. You could read this, right, pretty well, even though it's just a bunch of gibberish and it's complete nonsense. But research shows that you're able to, as long as the first letter and the last letter are in the correct place, you're generally able to read through whatever is placed in front of you. So you can do this because of top-down processing. Now, let's look at this example. Okay, in this case, what do you see? Right, you see a couple things here, okay? So these were actually cookies that were sold back at Starbucks during Christmas time, and they were taken off the shelves pretty quickly, and if you can imagine why, all right? Generally during Christmas time, we associate it with scarves, right? And sweaters and all of these winter accessories, right? But if you look at this too, it looks, you could say that it looks like that polar bear's throat is being cut, right? So it looks kind of violent at the same time. So as you can see here, this is we could call this context effects as well, right? When a given stimulus has radically different perceptions of meaning to two different people, right? Or also perceptual sets, right? When we have one thing, it looks like it could mean one thing, but it actually could also mean another. So this is a good example of context effects and top-down processing, right? When we look at it, sometimes we look at things in life and through our own experiences, we only see it through our eyes. We don't really see it through others. And so this is also a downside to top-down processing. We don't see things necessarily to how they really are, right? Or how someone is trying to present information to us. So referencing what we were just talking about there regarding perceptual sets and context, let's look at another example here. If you see these boxes, right, our experiences with that middle box changes regarding the flanking stimuli on the outside, right? If it's 12 or 14, the middle box is 13, right? If it's A or B, the flanking stimuli, then the middle box is B, correct? So this happens because of priming, right? You could also call that priming. Priming, from what we see before, affects our context influence, right? And therefore affects our perceptual set. So priming, and we'll talk more about priming later, but yeah, that's basically what priming is. So let me give you another example of priming context influences and perceptual sets. Okay, this image right here. Generally, I do a little thing in class with this, but this is a perceptual set. Why is this a perceptual set? Because I could prime you two different ways, right? I could say, hey, group one, think of a campus university in America during the wintertime. And then look at this image. And then for my second group, I could tell them to think about a retirement home during the wintertime. And then ask you to look at this image, right? And what does this image show us? It shows us an older woman, right? If you can see it. Okay, and then it also shows us a younger woman. Okay, there's two things going on here. But regarding how I prime you to see the image, it affects your perception of it. Right, here's another example. Let's say I tell you to look at this rabbit. Think about a rabbit. Picture a rabbit in your mind. Okay, look at that image. What do you see? You see a rabbit. Okay. Now, if I tell you to look at if I tell you to look at this a second time, think of a duck. What do you see now? Okay, this is another example of a perceptual set because this image has two different things that it's displaying, and we can see it differently two ways. And it all depends on the activation of certain associations, right, that we make affecting our perceptual hypothesis of how we respond to it. Now that we've talked about how we analyze specific features and form the gestalt, right, the whole of something, we're going to talk about the thresholds that need to be reached before we can ever perceive anything, right? Because if we can't pick up on that stimuli, then we're never going to be able to form meaningful wholes. So we have absolute threshold and we have difference threshold. So absolute threshold is the minimal stimulation you need to detect something, right? And we'll detect that particular stimulus 50% of the time. So an example of this would be basil in your spaghetti sauce, right? You've got to have a certain amount of basil in your spaghetti sauce in order for you to taste that. Same thing goes with audio, okay? Auditory stimuli, sound waves. So when we look at the difference threshold, the just noticeable difference, you could hear either or. This size, the size of the difference here, you're noticing a change in that stimulus, right? It's either gotten louder or it's gotten quieter, right? It's either gotten heavier or it's gotten lighter. If I pick up a 5-pound dumbbell and I pick up a 10-pound dumbbell, I'm going to be able to notice the difference between those two stimuli. If I take the volume on my radio and I go from volume 5 to volume 10, I'm probably going to notice, hey, you got the radio got louder. So that would be a difference threshold. And then you have subliminal thresholds, or you'll hear this called subliminal messages. You might see these studies on this stuff or articles on this online regarding like advertisements, commercials, politics, how subliminal messages are used to influence the unconscious of people. But it's controversial studies. So you've seen this used. Coca-Cola, they say Coca-Cola used to use it and also popcorn concession stands used it to increase the sales of Coca-Cola and popcorn at the movie theaters. Studies that were done on subliminal messages, they say it's a bunch of bogus. And it was also used in 2000 during the 2000 election in the U.S. presidential election for President Bush and Al Gore. They said President Bush in his campaign commercials. I'm sure he wasn't like in charge of this, but the campaign ads put the word rats right before the word bureaucrats was used whenever referencing Al Gore, his opposing candidate. So I don't know. That's just some examples of subliminal messages being used. Okay, so here's our last law we're going to look at regarding thresholds, and this would be Weber's law. So how long does it take for you to notice the just noticeable difference, right? Or the difference threshold? Generally, if you look at this, you can tell that when looking at Psalm 23 here, these stanzas, if you go from here, well, let's not use that one. That's not a good example. But if I go from this he to this he, I can tell the just noticeable difference, right? However, Weber's law tells us that the size difference of the threshold will vary by a specific or constant percentage in relation to the previous stimuli. So what do I mean by that? Okay, it's a little more difficult for me to show you that with this, but it's easier for me to explain it with music, okay, or with sound. So if a stimulus intensity is really high, so let's say I turn up the radio really loud, it's on volume 50, and then I change it to 55, you're going to have a difficult time noticing the change within that stimulus, right? Whereas if the stimulus was low, say on 5, okay, if I had the radio on 5 and then I turned it up to 10, I'm still only going up 5 clicks technically, right? You're going to have a much more easy time noticing that difference, the just noticeable difference, okay? So Weber's law is, again, it's just basically stating that there's a certain constant percentage in relation to the previous stimuli intensity that allows our ability to notice the change in the stimuli. Hopefully that makes sense. Okay, and I'll post a video on this of a guy actually doing this demonstration in his car, and I think it'll be really helpful for you to understand this principle. That one can be a little confusing. Now, what would you answer in this question? Here's an example. Imagine a man who wants to buy a 3-piece suit and a sweater walks into a store. If you were the salesperson, which would you show him first in order to get him to spend the most money? Would you have him buy the suit first or the sweater first? Okay, using these principles that we've just been talking about regarding threshold, how would you do this if you were a salesman? Okay, go ahead and answer this in the comment section. So now you've had a chance to answer this. So what would he have done? What would the salesperson have done, or what would you have done? Okay. Well, hopefully you said you would have tried to get this individual, this person, this customer, to buy the most expensive item first, right? Get him to buy the 3-piece suit first, because suits are expensive, right? I mean, a suit can cost you easily $800, $900 grand, or not grand. $800 or $900, right? I'm talking U.S. dollars. And so, if I can get you to spend $900, I could probably get you to buy the $80 sweater versus the $30 sweater, because you've just spent a ton of money. And they do this all the time. Like when I went to buy my wedding suit, he got me to buy a more expensive tie because I just spent $1,000 on my suit. So it was like, I just spent $1,000 US on a suit. Like this tie, how much is this tie? $120. Okay, whatever. I didn't notice the difference as much, and this is because of Weber's law. Last thing I want to talk about today, sensory adaptation. Okay, sensory adaptation is the gradual decline in sensitivity to a prolonged stimulus. So, and the reason why it's important to us is that it allows us to focus on other information around us, other stimuli that is changing, okay? We're not constantly focusing on unchanging stimuli, because it would just be really unpleasant and really difficult to function if you constantly felt your shirt on you, right? If you constantly felt your socks and your shoes and your glasses on your face and your face mask now that we have to wear all the time, which I always feel the face mask, so I don't forget it's there. But my glasses, right? My socks. I don't feel my socks right now. But when I put them on, first I feel them. Same thing with water, right? When we go swimming, it's a little chilly when we jump in that pool at first, but eventually we don't really notice it because the temperature stays the same. It's unchanging. Okay. Now we also have this thing called after effects, which is pretty interesting. And after effects, it relates to our sensitivity regarding taste. So, for instance, if you place something sweet on your tongue for a long period of time, or a long enough period of time that your tongue adapts, your gustation adapts, and then you drink water, well, of course, it will lose some of its sweetness. It won't be quite as sweet. Then you drink some water, what happens is it becomes sour. The water tastes sour. But the opposite occurs with if you put something sour on your tongue, right? Let's say you bite into a lemon, and then you drink water right afterwards, what you'll notice is that you have a sweet taste in your mouth. So these are called after effects. All right, so here's your exit ticket for this video. I would like you to compare and contrast. Okay, historical thinking skill actually. Compare and contrast the sensation versus perception, top-down processing versus bottom-up processing, change blindness versus inattentional blindness. You should have read about that in your book. Absolute threshold versus difference threshold. Okay, and then lastly, I want you to give me an answer for perceptual sets and how they influence how we interpret our emotions. Give me an example that we did not talk about in this video and that is not in your book. All right, that's it for today. I will see you guys later.